Okay, well, welcome everybody. Good afternoon, and thank you very much for joining us for this digital conference. The topic will be standoff, MCM, capability solutions. I'm Anthony Penn from ECHA Group. I'm the Commercial and Business Development Director.
And I'm Emeric Torcy, marketing responsible for drones operation in Nova Group.
And it's a great honor for us to have with us today the Admiral Dupont from the Belgian Navy, who will kindly say some words in introduction. Thank you very much, Admiral.
Thank you. In the context of mine countermeasure, the idea of increasing the distance between the ship, the crew, and the threat is not really new. In the NATO's Maritime Operational Study, MO 2015, it was already seen as a lot of shortcoming. They were placed in three different areas. The first was the speed of operation, the second, the safety of the crew, and the third, the way to introduce advanced technology to counter the threats. It was at that time already clear that current platform could not provide a suitable answer to all these challenges. Already in the 90s, navies implemented the self-propelled variable depth sonar. But these were still linked to the ship through the umbilical. The first introduction of a pre-programmed unmanned underwater system dates for the Belgian Navy from 2002 with the acquisition of a rMCM-type autonomous underwater system. The vehicle was not really autonomous because the decision-making algorithms and the reconnaissance algorithms were not yet very mature. So we cannot rely on these automatic systems to do the job. The data processing after the return was also time-consuming, making the use of several vehicles to speed up the process almost inoperable. Since then, the technology evolved, but the mines are still not completely convinced that we can get the ship out of the minefield and you can rely completely on the intelligence on board of the systems in order to clear an area out of mines. In order to validate and to refine the concept, but also, and perhaps above all, to convince people and show the validity of the concept, the Belgian and the Dutch Navy organized war games with other European navies and challenged the industry to propose autonomous systems capable of detecting, classifying, identifying, and neutralizing several types of mines in a representative area of the North Sea. The results obtained by the proposed system were then compared with the one coming from manned legacy platforms. The idea was to show that the new system were able to perform as good as our current legacy system. Two large-scale trials were organized in 2016 and 2017. After this campaign, it became clear that technology was indeed present. We were now ready to take the next step towards the deployment of autonomous systems and to address most of the shortfall of MO 2015. To do this, we were looking for a reliable partner to carry out this small revolution in the field of the mine countermeasures. This partner was chosen after a competitive bidding process involving several manufacturers, and I will now give him the floor to present the solution chosen, the technological challenges taken up, and the prospects offered.
Thank you very much, Admiral. So the Consortium created for the Belgian and Netherlands program was Belgian Naval and Robotics. The teaming of Naval Group and ECHO Group was to combine our strengths to build a very strong solution and then finally be selected by the Belgian Navy. So within the team, we have Naval Group, who are European leaders in military shipbuilding for conventional and nuclear surface ships and submarines. An ECHO Group, who are experts in robotics and autonomous solutions, and a world reference in mine warfare. Firstly, the solution proposed was offering considerable operational gains. Safety. So safety matters to all of us. And the key part of this standoff solution is keeping the man out of the minefield, and therefore reducing the risk of human exposure during the mission.
So the first idea is to keep the ship out of the minefield. But to complete this idea, we have designed a real warship. So to protect the crew. And first, it is designed to have a very NATO standard low signature regarding electromagnetic, acoustic, radar, and of course, a very high shock resistance. Then you have to protect the crew with, as it is long-lasting operations, with the comfort of the ship and its ergonomy. And this is fully optimized on the ship.
The solution also benefits from mature and sea-proven drones. So these were existing drones that, for the needs of the program, have been adapted and are currently being modified to meet the final requirements of the Belgian and the Euronaval navies.
Okay. So this solution, the other operational gain of this solution is that it is fast. And to do that, we have first developed a full and advanced automation on board. Thus, the drones and the drone flow can be optimized, and the preparation, the operation, and the re-rolling of the different many drones on board the ship can be done at the same time in an optimized way also.
Yes, of course, the speed is gained from a full range of drones that are working together. As we can see in the picture, there's a certain number of drones that are operating throughout the different phases of the mission, and these can be worked at the same time. Therefore, in parallel tasking, we are optimizing the mission time and increasing our productivity throughout the mission to accomplish it with greater speed.
So how is the standoff concept implemented on the MCM vessel? Let's see that together. So first thing was to design the MCM vessel as a real warship. And as you can see, all the Naval Group experience in first and high intensity combat frigates is there on this vessel. As you can see from the shape, it is of course kind of stealth, and it has also low signature regarding electromagnetics, acoustics, and radar. and it also complies with NATO standards regarding shock resistance. The ship is also fitted with a real combat management system that allows it to be embedded in a task force and to have a strong escort. Next, please. Now, the masterpiece of the ship is its mission bay. As you can see here, this is where all the unmanned vehicles are stored. So it is very compact, it is optimized, it has many devices to re-roll and configure the two USVs you can see there, and all the UUVs that goes on it according to what is wanted for the mission. And it can be prepared, operated, and re-rolled in a very easy way, an optimized way. And it is placed in the steer point of the ship, and that combined with the technology it uses can make operation so we can have operation up to sea state 5, which is quite a high standard. Next, please. And this mission bay is connected to the combat management system. This is a real combat management system that allows the mine operation to be conducting completely embedded in a task force and with its full escort. So the tactical picture is shared there, and thus the mutual protection is enhanced. It is a data-centric combat management system, and all the data collected can be shared for many purposes outside the ship. For instance, with the hydrographic databases, with the simulators, so that the training scenarios can be as close as possible from real-time operations. But also, as it is data-centric, all the data center on board allow the ship to work disconnected from ashore if required for any reason. And of course, all of this is cyber secured by design.
So the toolbox. The toolbox, very comprehensive, based on the UMIS solution offered by Echo Group. UMIS is unmanned MCM integrated system. So as the name implies, it's fully integrated. So it is a ship-borne, fully integrated system. Now this was key in being effective with the overall design of the solution, allowing a new concept to operate fully and easily on board the ship. Now, having said that, it also needed to be, according to requirements, containerized for an in-the-box possibility, therefore being used off-board at any time as necessary. Now, within the solution, which is in three stages, we have the software package. The complete software package called UMIS has 3 modules. The mission management module, which is aiding the operators at planning and following the mission at any time. The objective here is to make things easy. Therefore, through predictive planning, we are helping the operators understand how to best carry out the mission. The software is helping the operator understand what each drone can actually carry out as part of the mission, and then matching that not only with the zone that it's needing to cover, but equally with the resources that are available on board to not only select the available assets, but as well to have the available operator skills ready to work as and when necessary, therefore having the best possible planning. It will follow and give a real-time vision as well of the current situation of the mission as it's running. The second part of the UMIS suite is the drone control. Now this is a common system that is enabling the operators to have familiarity whatever the drone may be. Therefore, with this single interface, we are again concentrating on the ease of use and making the operator as comfortable as possible throughout the mission using the software. And the final part of the UMIS solution is the data management. The data management is allowing the embedded technology on all of our survey vehicles to carry out automated target detection. Now, this target detection is therefore being carried out on board and transmitting therefore only the information of interest to the operator that's away in the safe zone. The data management also holds the database, which can be developed as knowledge increases, and therefore optimizing our capacity at classifying the different threats. The final part of our toolbox is obviously the drones. So the drones are made up from unmanned aerial vehicles that can be used for detecting floating mines, equally as a relay communication source. The USVs, so the unmanned surface vessels, which are carrying the different robots in and out of the minefield, and equally acting as a relay communication. And then the detection vehicles for the survey, so whether it be a towed sonar, manned portable AUV, or a mid-size AUV. And then finally, the inspection vehicles and the neutralization vehicles. So as you can see, carrying out all 4 phases of the mission, from detection, classification, identification, and then neutralization. So some of the advantage of this drone system that can offer is, as explained, it's collaborative and interoperable. So many vehicles, many drones can be in the water at the same time doing the job together. Now, as mentioned previously, it's safe. We are keeping the man out of the minefield. Now, because these drones can be containerized, we're allowing as well the possibility with the solution of having an aero transportable solution in case the forces need to be projected elsewhere. A further advantage is the commonality. Now, commonality brought certain advantages with regard to the design of the mission bay. The fact that it was common launch and recovery systems for the mid-size AUV and the towed sonar allowed us to have a common system, which therefore was reducing downtime. So there was little or no reconfiguration of the USV when it was going from the AUV to the towed sonar. But equally, the logistic footprint was greatly reduced within the mission bay, having one common launch and recovery system for the different vehicles. Now, commonality equally brings advantages with training. Once the operator is familiar with one vehicle, because these bricks are found throughout the whole of the solution, we're reducing the training and creating a greater familiarity with all of the vehicles. And then finally, through maintenance, with the fact that the commonality is reducing spare parts, that again is having an impact on logistics and the footprint on board the mission bay. Now, the simulation is integrated with the training to allow the fact that the operator is completely at ease and can, in completely mastered and managed situations, carry out the full mission. Now, with the toolbox, we have a completely scalable configuration. The requirements of the Belgian and the Netherlands navies were to have a pool of toolboxes. So therefore, what that allows them to do is to configure each toolbox used potentially differently, but more importantly, configured to the different mission requirements, therefore being sure that everything is optimized on the mission and having the greatest efficiency possible throughout the whole of the mission. Thank you. I would like to hand over now to the Admiral for some further words in conclusion.
Before that, I would like to show you the contrast between what was and what is mine hunting now and what we foresee it to be in the future with a short teaser.
Computer.
Thank you. The floor is yours, Javier.
Thank you. We are convinced that the approach adopted contains the possibility of adapting the toolbox to the current operational situation, but also of introducing new sensors or new autonomous systems more easily. So we continue to evaluate current UAVs in exercise where the performance of current autonomous system far exceeds what we can expect from current legacy systems. This ongoing evaluation, in collaboration with industry and partner nations in the framework of PESCO and the MUS initiative, will lead us to the toolbox called 2.0 through 3.0 and future toolboxes for greater safety of the crews and enhanced freedom of navigation worldwide. Thanks to the constant work and the excellent collaboration between the teams of BNR and the project team at Defense, the contractual milestone have been achieved both in terms of deadlines and products, and the delays to the current health crisis remained limited. To celebrate this partnership, I will now hand over the official logo of the program to the BNR. We will now unveil it together. It shows the philosophy of the Belgian and Dutch Navy's MCM replacement program, an innovative binational program built around a resilient platform, operating away from the sea mines, serving as a base for the deployment of unmanned systems operating in the three dimensions, the air, the surface, and underwater. Thank you. I think that we now can go over to the question and answer session.
Yes, thank you. If there's any questions, we'll be very happy to answer them now.
Well, I have seen one question concerning the USV, if it was possible to interchange it within the hangar, and that is possible, so it's an affirmative. It's not, of course, a usual mode of operation, but we can do it. We can interchange both USVs from one Lars to the other.
Thank you, Rick. And thank you, Claude, for the answer.
You're writing.
There. Any more questions?
Yeah. Will MCM divers be used?
MCM divers will of course still be used in the future concept of operations, and we will use either the USVs for that, because it is foreseen that we have a specific payload for divers. But of course we have also SOLAS ribs on board that can be used for that purpose as well. It will depend on the mission that will be chosen.
So the next question is the launch and recovery ready for the toolbox 3.0? The answer is yes, because it is designed as very modular. So the changes to be done to adapt are very limited. So it is or almost is.
main milestones.
Claude, if you
I don't see the question.
Okay.
publish the question of the delivery capability. Yes.
D'accord.
The main milestones. No. To be let us see.
Which are the following main milestones of the program to deliver the capability?
Well, I can also answer that one. The next milestone is the preliminary design review, where we will, in fact, just have the final, almost final configuration of the ship, and all the systems will be chosen. And after that, we will have the critical design review, with an important milestone is the first steel cut for the building of the first ship. That will happen in in June 2021.
Training burden. The training burden of such system.
The training burden, well, of course, we will have a modular cruise. That means that each module will have a training session prepared well in advance. So we have the crew, basic crew for the mothership. That's the first part. And then for each tool, we will need some training, of course, for those modules. So we have a maximum capacity of 63 persons on board with a basic crew of 30 persons. So the remaining will be used to embark the people that are necessary to operate the modules.
And maybe we can add that it's a complete systems when we will have ashore new modern facilities to train the people before they are going on mission on basic skills, but also we can also provide missions oriented training before the people were embark on board of the ship and will be deployed.
Yes, you have to know that we will have a simulator in Egermin, École de Guerre de Mines, the NATO Center of Excellence for Mine Warfare. The simulator will be embedded in Ostende, and parts of the crews will be trained over there. And the training will consist of the CIC, the Combatant Information Center module, so the operational part, the handling of the systems through the mine warfare software, but also the handling of the tools in the hangar will be possible to be trained by virtual reality modules. Okay.
Okay, there's a question about are there other UMIS configurations or compact integrable on existing ships? The answer is yes, completely the principle of UMIS. As from when we can carry out the complete mission and fulfill the 4 phases of the mission, everything is configurable within. So we can go from the man-portable to the mid-size AUV and the towed sonar for all of the detection phases. These can be done with or without the USV as well. And then the inspection and mine neutralization phases to finish the mission. So being containerizable, this can then be used, as I mentioned, either from shore or from a ship of opportunity if necessary. So yes, completely scalable and completely reconfigurable according to the requirements. The next question, the way is to go to the unmanned world, but do you think that could be a risk to not continue the legacy MCM? I mean, the risk to lose the legacy MCM know-how, traditional MCM with ROVs from MCMV or divers.
I think it's a question for us, but to be honest, we are not seeing the question on the screen, so it's.
So really, it's a question about what are the risks of moving to unmanned solutions with regard to losing know-how through traditional methods, conventional methods.
But that, of course, it can be considered as a risk. But as said by the Admiral, we had some wargaming going on to just check if it was feasible. So the conclusions of all the wargaming and all the testing that we did with real life systems were conclusive in the sense that that we think that the risk is limited. Of course, we are still developing some domains of mine warfare, but in our opinion, it's not a high risk. And it's of course we will have many tools to do the operation.
And also during the transition phase, so it's always the same when you are introducing such a new way of doing things. There are some years where the two systems will live together. There are already some measures who are taken in order to be sure that we are able to manage it. So, for example, in Egermin, we will not dismantle the current training facilities to install the new one. The new one will be installed a part of the old one. So at one time, the both training facility will exist together. So we still have the possibility to do it all together. It's the same regarding the maintenance. And when you are looking at the skills of the crew, you have to know that we are in the Belgian Armed Forces in general, and in the Navy, it's not an exception. We are in a situation where we have a large bunch of people who are, I should say, closer to the end of their career than from the beginning. And the idea is really that we will pick up most of the new people in the new system and having the all experienced people still working on the legacy platform until the moment that the legacy platform will be removed from service. And so that's the mitigation measures that we want to take to ensure that at one time we keep up enough capacity to countermine before our new one will completely be in FOC.
Well, if there's no further questions, then I'd like to round up the conference. And once again, thank you very much to the Belgian Navy and the Admiral Dupont for accompanying us on this digital conference. I hope it was instructive and interesting for all of the participants. And please don't hesitate to go on to respective websites to find out more and get in contact with us if you need more information. So thank you very much and goodbye.
Thank you.
Bye.
Bye. Come on.